Okay, we're going to do lesson 2.1. So it's a little complicated. These notes actually start on the back of your last notes. So right where the word problems ended is where this set of notes is going to begin. And then after we're done with this little bit, then we'll move on to your new note packet. So number one says, is it a polynomial function? Well, I think we've talked about this sort of thing before, but let's do it again and make sure that we've got these rules down. Is it a polynomial function? Well, I will tell you right now that 2x squared plus 3x minus 1, that's a yes. That is a polynomial function. So is D. And so is E. These are all yeses. All right, so these are our yeses. Let me see if there's any more. And so is F. So these are the yeses. Now, let's talk about why the other ones are no's. If you were here, you'd all be telling me that B is a no because you're not allowed negative exponents. No negative exponents are allowed. So B is a no because you're not allowed to have negative exponents. C is a no because you're not allowed to have x in the denominator. So if your problem has an x in the denominator, it's not a polynomial. If your problem has a negative exponent, you are not a polynomial. G, no fractional exponents are allowed. No fractional exponents are allowed. And H, no x under the radical. Okay? So, we need to know these rules. There'll be a section on your next test, I promise, that says, is this a polynomial function? The rules are, you are not allowed to have a negative exponent. You are not allowed to have an x in the denominator. You are not allowed to have a fractional exponent. And you are not allowed to have x under a radical. So as long as you don't break any of those rules, you're a polynomial function. So that's why this one's fine. And this one's fine. And this one. Now, this one you might be a little confused about, but pay attention. Is the x under the radical? No. No x under the radical, that's the rule. So if it looked like, well, that one is x plus 2. No. If it were root 5x, no. But this one, the 5 is under the radical, but the x is not. And that's okay, because the rule says no x under the radical. Okay? All right, so those are our rules. All right, number 2 says, write the equation of the linear function if f of 2 is 3 and f of 1 is 5. Now, you're not going to believe this, but you've already done this problem many, many times. Even without me this year, we've done this problem. Because, remember in function notation, the guy in the parentheses is x, f of x. So x is 2. This is actually the ordered pair 2, 3. It is a fancy mathematical way of writing it, but it literally is an ordered pair 2, 3. This one is the ordered pair 1, 5. Whatever is in the parentheses, f of x, f of 2. That is the x number, and that's the y number. This is the x number, and that's the y number. So we're writing the equation of a linear function. Basically, we're writing the equation of a line. So to write the equation of a line, you know what we need. We need the slope. So the slope is 5 minus 3 over 1 minus 2. Y minus y, y's on top always, y minus y, x minus x. So that's 2 over negative 1 or negative 2. So my slope is negative 2. Now I pick a point, I'll just pick that one, it doesn't matter, pick either point. Y minus the y coordinate equals slope times x minus the x coordinate. So remember point slope form, y minus y equals m times x minus x. So y minus 5 equals negative 2x plus 2 if I do the distributive property. And then I'll go ahead and add the 5. So it looks like my answer is y equals negative 2x plus 7. Now, one of those tricky little things, it does say, right, a linear function. So I'm going to change this y into function notation. Now, I know what some of you are thinking, oh, do we have to do that? Yes, if we want to follow the directions, that's what we're going to do. When it specifically says write the equation of a function, then we should use function notation. All right, now let's transition over to our new note packet, and we're going to do the same thing. F of 3 is 6, and f of negative 4 is negative 1. So this is 2 ordered pairs, 3, 6. Remember, it's f of x. When you get confused, remember f of x. So inside the parentheses is the x. 3, 6, negative 4, negative 1. Did I copy that right? Yep. So we're writing a line, so we start with slope, negative 1 minus 6, and negative 4 minus 3. So negative 1 minus 6, negative 4 minus 3. So let's see, that's negative 7. Oh my gosh, did you get 1? Your slope is 1. Pick a point. I'll pick that one because it looks easier. Y minus 6 equals 1 times x minus 3. Guys, if you don't remember how to write the equation of a line, you need to come in for office hours. Point slope form, we've been doing that for a long time, so we need to know how to do that. So y minus the y coordinate equals slope times x minus the x coordinate. So y minus 6 equals x minus 3, and y equals x plus 3 if I add 6 to both sides. F of x equals x plus 3, and that actually is the answer. Okay, now we have some review work, which is actually good practice for your test. So I'm looking at problem 3 now, 3a, and I have this equation. And I'm to find the vertex, axis of symmetry, and direction of opening. So that's my like abbreviations there. Vertex, axis of symmetry, direction of opening. Now, before you get confused, what shape is that? It's a parabola. It's x squared. Parabolas are, x squareds are parabolas. So if I draw this, I know that this parabola has been moved 3 units left, or excuse me, 3 units right, and up 4. So remember when I always had you label these points? Keep labeling them. This one went 3 right and 4 up. So there it is. Now, that 2, don't worry about it. It doesn't have anything to do with this particular problem because all that 2 does, remember, is stretch the parabola. And that doesn't change the vertex. So the first question says, what's the vertex? Well, it's 3, 4. The second question says, what's its axis of symmetry? Now, the axis of symmetry is the crease. If you could somehow fold this parabola in half, the axis of symmetry would be that crease. And notice that it is a vertical line that intersects the x-axis at 3. Its equation is x equals 3. The axis of symmetry will, for a parabola that opens up or down like this, the axis of symmetry will always be x equals whatever that is, because it's always going to run right down through the vertex. So it's going to be x equals 3. And then, of course, this parabola opens up. All of our parabolas open up unless we do what? Unless we put a negative out here. When you put a negative out there, what does it do? It turns your parabola over. All right, let's try the next one, B. Now, don't be confused by this. What does this tell me? I'm going to go 1 unit to the left. Now, have I gone up or down at all? No. So my vertex is just over here 1 unit to the left. So it's at -1, 0. This tells me I go left 1. So if I go left 1, I'm at -1, 0. That makes my axis of symmetry x equals -1. Remember, it's always going to be the x coordinate. And then this one also opens up. They all open up unless you put a negative out here in front. That's what turns them upside down. All right, y equals -2x squared plus 4. How has this one moved? Remember, parabolas, squaring functions, start at the origin, but we move them around. Now notice, I got a plus 4 out here, but it's not in the parentheses, it's just plus 4. So this parabola has been moved up 4. And because of the negative, it's opening down. So its vertex is 0, 4, and it opens down, and its axis of symmetry is always going to be x equals the x coordinate. So its axis of symmetry is x equals 0. I bet you're getting the hang of this because so much of it's review. All right, so here we go. Let's take a look at this one. Where's its vertex? How have we moved this parabola? Well, this tells me that I went 1 right, and that tells me that I went down 2. So 1 right, down 2, puts my vertex at 1, -2. You can tell that just from looking at the equation, based on what you already know. Now, the direction of opening is down. How do I know? We got a negative out in front, and a negative turns you upside down. Parabola is supposed to open up, but when you put a negative out in front of it, it's going to open down. And your axis of symmetry is that line right there, which is the line x equals 1. We're not going to get confused about that, guys. It's always x equals the x coordinate, always. Oh, whoa, whoa, whoa. Isn't that our BFF? That's what we have memorized. We know exactly what that looks like. Its vertex is at the origin. It opens up, and its axis of symmetry will be x equals 0. And finally, I hope you got this one done already on your own. How have we moved? 2 units right and 1 unit up. So our vertex is at 2, 1, over 2, up 1. We open up. Remember, we always open up unless there's a negative out in front. That's how you turn it upside down. And so it opens up, and the axis of symmetry is x equals 2. Always x equals the x coordinate. Now, as long as the equations are written in this form, by the way, this is called Vertex Form, because from looking at it, you can tell the vertex, right? Vertex Form, you can tell the vertex just by looking at it. As long as it's written that way, then filling these in is easy. We just went through a whole bunch of them, and boom, 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 easy, easy, easy. There's no work to do, just boom, you know it. We'll look at number 4. That is not in vertex form, because vertex form requires you to have something just, a quantity squared, and we don't have that. So I'm going to change these directions. I want you to go ahead and cross out where it says write in vertex form. I am not going to require you to rewrite the equation. So cross off where it says write in vertex form on number 4. Cross off write in vertex form. But we are going to find the vertex, axis of symmetry, and direction of opening. The direction of opening is a no-brainer because there is not a negative in front of the problem. If there is a negative in front of the problem, you open down. Otherwise, you open up. No-brainer. To find the vertex, you are not going to be able to look at your equation anymore. You're going to have to do some work. We're going to use what's called the axis of symmetry formula. And it is super simple. You may have used it before. X equals negative b over 2a. That is going to give me my axis of symmetry. Remember, the axis of symmetry is x equals something. And this is going to give it to me. When you look at this equation and you think about the quadratic formula, you would tell me a is 1, b is negative 2, and c is 2. The same a, b, and c that you've used forever with the quadratic formula. Negative b would be 2, over 2a would be 2 times 1, which is 2. So my axis of symmetry is x equals 1. My axis of symmetry is negative b over 2a. Do the arithmetic, comes out to be x equals 1. Now remember that the axis of symmetry matches the x coordinate of the vertex. So if I know my axis of symmetry is x equals 1, then I know my vertex is 1 comma something. The axis of symmetry is the x coordinate of the vertex. So once I've used my formula to find my axis of symmetry, I now know the x-coordinate of my vertex. So I'll find the y-coordinate by going back to the equation and plugging in this case, 1. So y equals 1 squared minus 2 times 1 plus 2. 1 minus 2 plus 2, I think that just works out to be 1. So your vertex is 1, 1. All right, let's look at the next one. 2x squared minus 8x plus 10. Your job is to find the vertex, axis of symmetry, and direction of opening. Direction of opening, no brainer. See that 2 right there? It's positive. That means it opens up. I'll say it one more time, and I'm not going to say any more. The only way a parabola is going to open down is if there's a negative out in front of it. If you don't have a negative out in front of it, it's not opening down. It's going to open up. Now, this is not vertex form, so I'm going to use my formula. So x equals negative b, that would be positive 8. It's the opposite of b, over 2a. So it's 8 over 4, which is 2. So my axis of symmetry, that's what this is the formula for. The axis of symmetry is x equals 2. The vertex is 2 comma something then, because the x-coordinate of the vertex is the same as the axis of symmetry. To find the y of the vertex, we're going to take our x and put it in. So y equals 2 times 2 squared minus 8 times 2 plus 10. Now, if you got to use a calculator, use a calculator. This is 2 times 4, which is 8, minus 16 plus 10. So that is, oh my gosh, is that 2? Okay, they don't always match. They just happen to match on both of these. That doesn't always happen. I don't know, I think my arithmetic's right. So we end up with a vertex at 2 comma 2. Again, they don't always match. That is coincidence. We're going to do some more, and I bet they won't match. All right? All right, so here we go. I'm going to do my axis of symmetry again. And this time my equation is 1/3 x squared plus 4/3 x minus 20/3. So I'm going to do my axis of symmetry. So I'll do negative b, so the opposite of b, over 2a. Now remember, when you multiply 1/3 times 2 over 1, it's just 2/3. Let's not freak out about the fractions. This arithmetic is super simple. It doesn't get more complicated. It is fine. So this is negative 4/3 divided by 2/3, which is negative 4/3 times 3 over 2, which you can either cross cancel or just multiply and get negative 12 over 6, which is negative 2. So my axis of symmetry is x equals negative 2. So negative b over 2a, so 2 times the third is 2/3. Negative 4/3 divided by 2/3 is negative 4/3 times 3/2, which is negative 12 over 6, or negative 2. That means that my vertex is negative 2 comma something, because the axis of symmetry always matches the x-coordinate of the vertex. And now I'm gonna have to plug in -2 into my problem. I am not freaking out though, because they have a common denominator, so adding them up is going to be easy. So I have 1/3 times -2 squared plus 4/3 times -2 minus 20/3. To get my y-coordinate, I put my x-coordinate back into my equation for the x's. So this is 1/3 times 4, which is 4/3. This is 4/3 times 2/1, which is -8/3, and that's -20/3. So 4/3 minus 8, well, let's just do 4 minus 8 minus 20. So 4 minus 8 minus 20 is -24/3, which is -8. That's a positive 1/3, so it opens up. I really don't want to hear a bunch of whining about the fractions, kids. That was easy. Fraction work, fractions are part of our life. You know how to do it. You may not like doing it, but you know how to do it. Don't let that mess you up. One more. We're going to find the vertex, axis of symmetry, and direction of opening, which I know right away is down. Is that negative? Down. All right, here's my formula. X equals the opposite of B, which is 3, over 2 times A. Well, kids, this is going to be an easy one. What's 2 times -1/2? Isn't that just -1? So my axis of symmetry is -3, and that means the x-coordinate of my vertex is also -3. -b over 2a, and 2 times 1/2 is 1. So now I'll plug -3 in, so I have -1/2 times -3 squared minus 3 times -3 minus 5/2. Well, -3 squared is 9 times -1/2 is -9/2 plus 9 minus 5/2. Let's do the fractions first. -9 and -5 makes -14. Divided by 2 is -7 plus 9 is 2. So there's your vertex, your axis of symmetry, and your direction of opening. You are not responsible for putting an existing equation into vertex form, but you are responsible for being able to find the vertex, axis of symmetry, and direction of opening. And the easiest way to do that is to use our axis of symmetry formula. We just did several examples, and it's easy. Easy, easy, easy. All right, one more section, number 5, and then we'll be done with this. All right, so what have we got? We've got a parabola whose vertex is -2, -3, and who contains the point 1, 2. Now, I want to remind you of the problems we did first. They were written something like this. I'm making this one up completely, but they were written something like this. And I said, this is vertex form, because this tells me that the vertex, I would go left 1 and down 4. So my vertex would be left 1 and down 4. What you're doing now is going backwards. So if you know that the vertex is -2, -3, then don't you have to have x plus 2 in the parentheses and a -3 on the end? Wouldn't that tell you to move 2 left and 3 down? So that part's easy. We want to go 2 left, so x plus 2 will move us 2 left, and then -3 on the end moves us 3 down. What I'm missing is this random number out here in front. I'm going to call that number n, and now I'm going to figure out what that number is. So to start with, I just use my vertex, because my vertex fills in these blanks. Now, I need to find that number out in front, and that's what I'm going to use this point for. Because x is 1 and y is 2. So I will simply take that x, that y, plug it in this equation. So 2 equals n times 1 plus 2 squared minus 3. Remember, you had already started your equation by putting in x plus 2 and minus 3. Now I'm filling in this other random point, putting y is 2 and x is 1. Now I'm going to work it out. So 2 equals n times 1 plus 2 is 3, squared is 9, minus 3. Now, I'm going to suggest that at this moment, you recopy that, so instead of having n9, you have 9n. Because if you write it 9n, you are not going to combine these two. They don't get combined. I have to add the 3 to the other side and divide by 9. So my answer is y equals 5/9 x plus 2 squared minus 3. All right, if that was a little too much for you, just hang on. We're going to do a couple more. Here we go. Ready for the next one. We know that our equation needs to look like that. We also know that this parabola has been moved no way sideways, but up 1. So its parentheses is x minus 0. Haven't moved it. If you want to write plain x squared, that's fine. That's what it is. You haven't moved sideways, but you have gone up 1. This would tell me, just stand back and look at it. This tells you that you're going nowhere sideways and you're going up 1. That's exactly what you want. Now what we don't know is this random 5/9 number out here. We don't know what that is. So we'll take our other point, not the vertex. The vertex builds the equation. This other thing, I plug in 3 for y and 7 for x, and I work it out. So 7 minus 0 is 7, squared is 49, plus 1. Do not add the 49 and the 1. You're solving for n, so you're going to subtract the 1 and divide. So we get 2 over 49. So your equation, y equals 2 over 49, x minus 0 squared plus 1, or if you prefer, 2 over 49, x squared plus 1. There is nothing added or subtracted to the x. Last problem, here we go. So what do we know? We know that whatever's happening with this guy, we know he has moved 2 units right and 1 unit down. One thing that does happen sometimes is we forget about that squared. Remember, we're writing the equations of parabolas, and parabolas are squared, x squared. You gotta have a squared in there. So this tells me I'm going 2 right and down 1. So that would be the vertex. What's missing is, I don't know what that coefficient is. Could be positive, could be negative, I don't know. I figured out. So I take this x and this y, and be careful, make sure you're putting the right thing in for the right thing. So I'm putting -5 in for y, and 4 in for x. -5 is y, 4 is x. So -5 equals, okay, 4 minus 2 is 2, squared is 4. So this is 4n minus 1. So I'll add 1. Oh, this one came out nice. I got -1. So my answer is y equals -1 x minus 2 squared minus 1. Or you probably wouldn't, but you could, right? Just negative x minus 2 squared minus 1. So this parabola, if I were graphing it, which I'm not, but if I were, that parabola opens down. All right, that's it. So, I'll let you know, your 2.1 homework is due sometime. I'll let you know when it's due. Have a great day.